Good morning, students. So today we were dealing with the chapter chemical kinetics, right? So in our last class we have learned about order, what is molecularity, how to write the rate law, and we have done some problems also. And please recollect some of the points that we have discussed in the last class, where I have told that the reaction mechanism can be of two types. It can be of elementary reaction or it can be complex reaction. Complex reaction happen in multiple steps, whereas elementary reaction happen in single steps. And I told for elementary reaction what is their molecularity and order will remain the same, correct? Okay, now I am going to an exceptional case that is called pseudo first order reaction. So what is pseudo means? Pseudo, sometimes we used to say pseudo promise. Pseudo promise means what? False promise, correct? So here I say pseudo first order reaction. So let's say what is the definition of this. Okay, so it is a chemical reaction in which the value of the order of the reaction is 1, but the molecularity is more than 1. These type of reactions are known as pseudo unimolecular or pseudo first order reaction. Okay, I will explain. So very simple. I told if it is an elementary reaction, usually order and molecularity will remain the same. This is an exception where the order and molecularity differs. Okay, order and molecularity is differing, correct? Okay, now let's see how it is. Consider the reaction. Example, CH3COO C2H5 plus H2O. What is this reaction called? We know that CH3COO C2H5. CH3COOR, it is an ester, correct? Ester reaction with water, that is called hydrolysis of the ester. Usually happens in the presence of an acid to indicate that H plus is given, correct? So hydrolysis of an ester, what will happen? It will convert this ester to acid plus alcohol. This will split into H plus and OH minus, and this will form C2H5OH, and this will form CH3COOH. Now in this reaction, if you see, I am not going into the mechanism of this reaction. This you will learn in the chapter aldehydes, ketones and carboxylic acids. Okay. Now if you see here, the expected rate, what you expect or how you expect the rate law to be. Rate law is K into constant times CH3CO C2H5, its concentration, multiplied by the concentration of water. This is the expectation. But what happens is, in this reaction, water is taken in excess. Understand? Water is taken in excess. If water is taken in excess, then we can say its concentration is constant. Now many students will think, sir, why it is like that? You can think of an ocean actually. Okay, you know ocean has plenty of water. Okay, and suppose if you remove one mug of water from the ocean, will you feel or can you say a change in the amount of water in the ocean? Actually speaking, there is a change, but we say it is still constant, correct? The same concept is used here. So the expected rate law is K times rate constant times CH3COO C2H5 multiplied by H2O concentration. But the actual rate law is K dash into CH3COO C2H5, where K dash is K times concentration of H2O, because K is a constant and concentration of H2O is also a constant since it is present in excess. Okay. Now if you see this actual rate law, you can see here only one unit is present, correct? Here order is 1, correct? Here order is 1. But if you see the molecularity, what is molecularity? The actual number of reacting species. If you see, this is 1 and this is 1. So the molecularity is 2, but the order is 1. Such a type of reaction, it is called pseudo first order reaction. So pseudo first order means what? Actually it is not expected to be first order, but because of this water which is present in excess quantity, this is becoming first order. So that's the reason why they are called pseudo first order reaction. Okay, I hope it is very clear for you. Very simple. So the value, we can say chemical reaction in which the value of the order of the reaction is 1, but the molecularity is more than 1. Such type of reactions are called pseudo unimolecular or pseudo first order reaction. Many examples are there. So the very fundamental example, if you write in descriptive exams also, you can write this one, hydrolysis of ester. Hydrolysis of ester will yield you acid, carboxylic acid and alcohol. Okay, and you should write there in clearly, you should write, since the quantity, since the water is present in excess, its amount or its concentration is taken as constant. So that's the reason why the actual rate law becomes like this. Okay. Hi dear students, so next we are going to learn a new subtopic under this chapter. The topic is study of different order reactions or integrated rate law. Okay, now this is from the continuation of the last topic. We have learned there are different orders are there, order is there, and order can be, we told it can be fractional order, it can be 0, it can be 1, 2, negative, right there. Okay, now we are going to learn about some of the important orders. We are not going to learn every orders, it is like we are going to learn 0 order, first order, second order. Then we will try to derive an equation for writing a general order. Okay, what will be the equation for a general order? So this is also called integrated rate law. Why it is called integrated rate law? Because very simple, here now you think about now the whole scenario. Why we are learning this chemical kinetics chapter? The reason is we need to identify or we need to find out the speed of the reaction, correct? Now the most important use case here is we need to identify the speed of the reaction between a time interval. For example, they say between whenever a reaction happens at time 0 and it completes after half an hour. They want to know what is the rate of the reaction between 14th minute and 15th minute. Like that, if they want to know, they can directly apply this integrated rate law, because we use here the concept of definite integration. Definite integration is a concept where that will give you the difference between two particular intervals. For example, we say upper limit and lower limit. For example, I want to find the rate law between 15th minute and 13th minute, means I will take the upper limit as 15th and lower limit as 13. So for what we are right now going to do is we are trying to derive equations for 0 order, first order and second order and for nth order based on integrated rate law. So if you know that equation, you can directly apply in your questions to identify or to determine the rate of the reaction between any particular interval or at any particular instant. Okay. So that is the idea of this topic. Now let's go, we will start the derivation of 0 order. Okay. So first is the 0 order reaction. Now first thing I am going to discuss is some of the important features of 0 order reaction and examples, very important. So most of the students here ask me one doubt, sir, whenever an equation is given, sir, how to identify whether it is first order, second order, or please understand, order is an experimental quantity that is determined experimentally only. So that's why we cannot see one equation and say whether it is a 0 order or first order. It is better that we learn examples from NCERT text that is given for 0 order reactions. So usually they will ask from that so that we can identify which order it is. Okay, you need to remember some examples. Okay, so here, so coming to 0 order reaction, so the reactions in which the rate of the reaction remains independent of the initial concentration of the reaction, initial concentration of the reactant, they are said to be 0 order reaction. How we are saying that? For example, if I am going to write the rate law of a 0 order reaction, rate law is equal to rate constant into reactant. This is the reactant concentration. If it is 0 order, what I will do? It is 0 we will keep right here, because this indicates a 0 order rate law. So in this case, any concentration raised to 0 means its unit is 1. So I can say rate is equal to K. Correct? So that means here the rate law or the rate of the reaction is independent of what? Initial concentration. Let the initial concentration be maybe 1 molar, or let it be some 10 molar, or let it be some 100 molar. Whatever be the case, since 0 comes here, that value or concentration becomes 1 and the rate law becomes rate is equal to rate constant. Or we can say 0 order reactions are those reactions in which the rate of the reaction will become equal to what? The rate constant. So that is what I have told here. So the reactions in which the rate of the reaction remains independent of initial concentration of the reactant, they are said to be zero order reactions. Okay. Now another important thing, so usually zero order reactions are relatively uncommon. That means most of the reactions might not be zero order, only very few reactions are zero order. Okay. So they usually occur under special conditions, and we can see some of the examples of that. For example, the reaction between hydrogen and chlorine to give hydrochloric acid. So here hydrogen is in gaseous state, chlorine is in gaseous state, and HCl what you are obtaining is in gaseous state. And another example is ammonia decomposition. So 2NH3 on decomposition gives N2 and 3H2. These are all examples of zero order reactions. So if it is an example of zero order reaction, how I can write? Its rate law will be rate is equal to rate constant. I don't want to write concentration of H2 multiplied by concentration of Cl2. So if I write like that also, for example, if I am writing for the first example, how I will write? K into concentration of H2, concentration of Cl2, correct? But if I write like this, I need to put here what actually, since it is a zero order, I will keep here 0. Again, this will become rate is equal to rate constant. Clear? So similarly for any of these reactions, if you write the rate law, finally it will become rate is equal to rate constant. Understood? So next example is reaction between acetone, CH3COCH3, acetone and bromine, and dissociation of HI on gold surface. All these are examples of what? Zero order reaction. Now next we will try to see how to derive an equation for zero order reaction, integrated rate law. Okay. Hi students, so we have seen what is a zero order reaction, correct? Its definition we have seen. Now let's try to derive what is called the integrated rate equation, or it's called differential rate law. Okay, so here if you see, I can say we are starting with the reactant A. Okay, it is getting converted to some product. Okay, so how will you write the rate law? Rate law is equal to minus dA by dt. Why minus is coming? Because it is a reactant that will keep on decreasing. Correct? So it is equal to rate constant K into concentration of A raised to the power 0. Why 0 is coming? Because we know it is a zero order reaction. So we have putting 0. So any concentration which is raised to 0, we know that its value will become 1. So this is equal to K. So we can say that now we are cross multiplying this. So minus of dA is equal to dt will come here. So we say K into dt. Now only we need to apply the integration. I mean the upper limit and lower limit. Now we say this a concentration of A at a time 0 is represented by A of 0. And we need to find the concentration at after a particular definite time period t. So we say at that point of time the concentration is A of t. Okay, that is AT. So please understand, A of 0 is the concentration at time t is equal to 0, and A of t is the concentration after a definite time t. Okay. Now here also you can apply time. So since dt is there, so initial time is 0, and after a time t this will come. Now you need to integrate on both sides. On integrating, what will happen? Just listen. So we can say that on integrating this will become, so if you see here, apply, so dA, so or dA on integration will become A, correct? And apply the lower limit A of 0, upper limit A of t, correct? If you have doubt, please remember this integration. Those who have learned integration, you might be knowing. Integral of dx will give you x. Integral of dt will give you t. Correct? So these things you need to remember. These are fundamentals of integration. Correct? So now tell me, here also minus k integral of dt will give you what actually? T. And the lower limit is 0, upper limit is t. Correct? Now apply the lower limit and upper limit. So while you are applying, what you need to do? Apply upper limit minus then lower limit. On applying the upper limit, A will become what? Substitute A of t here. So this will become A of t minus apply the lower limit to here. So A will become A of 0 equal to k minus k into, apply the upper limit t into this variable, that is t again, minus apply the lower limit 0 to this variable. So when you substitute 0 here, it will become 0. Okay, now we are already into the equation. So we can say that the equation is a of t minus a of 0 is equal to minus kt. So this is the equation, integrated rate equation or rate law or the differential rate law for the zero order reaction. Now how you can beautifully write this, a of t minus a of 0 is equal to minus kt. So here a of 0 is a constant because it is the concentration initially. So initial concentration is always fixed, right? So a of 0, that is whatever you are taken, that will remain the same. So its value is fixed, and this is the concentration at a time t, and this is the time taken, and k is the rate constant. So how you can rewrite this equation? Either you can learn it like this, a of t minus a of 0 is equal to minus kt. This can be the fundamental equation for a zero order reaction. Sometimes they will compare this with a straight line equation, y is equal to mx plus c. So this is a straight line equation. So here c is a constant, and similarly here a0 is a constant. So y is a variable. So I can write here in this format as how a of t is equal to minus kt plus a naught. So compare it, then it becomes very easy for you. So here a of t is the y variable is equal to mx. So xt is a variable. So I will write mx plus c, which is a constant. A of 0 is a constant. So tell me, what is the slope then? Slope of the zero order reaction. We know m is the slope. So on comparing it, we can say slope m is equal to minus k. Very, very important. So for a zero order reaction, what is the slope? So from the graph, if they are asking you, they will give a graph and ask you to find out the rate constant. So what you need to do, if you want to find the rate constant, we know the rate constant is k. So what you need to do, find out the slope. Slope is m, and we know that slope also have other formula. M is equal to tan theta. Correct? Very important. Slope can be found out by finding out the tan theta. So that tan theta will be equal to what? Minus of k. So that will be the rate constant. You can easily find out. Okay. Next we will try to see the graph of a zero order reaction. Okay. So let's try to see the graph of a first order zero order reaction. So that is concentration at any particular time t versus t. That means how the concentration is varying with the time. Okay. Now if you see the graph, we can draw the graph from this equation. A of t is equal to minus kt plus a of 0. Now into this equation, if I am putting time t at time t is equal to 0, that is initially. So if I am putting this one, this will become a of 0. This is equal to minus k into 0, and this is a of 0. So what does that mean? At time t is equal to 0, so at time t is equal to 0, what is the only concentration that is left behind? A of 0 or A0. So I can say A0, that is at time t is equal to 0, this is the concentration. Now what will happen at time t is equal to 1 second? So at t is equal to 1 second, we can say here A of 1 will become minus k plus A0. Correct? So whatever that is present there initially, a of 0 minus this slope. If you minus that slope, you will get probably at a time t 1 second you will get the concentration. So logically if you think, then also you can understand that at A0 the value was very high. Correct? It is equal to A0. Now at time t is equal to 1 second, the reactant concentration keeps on decreasing. So that's why initial concentration minus this value is coming, and you can see this has decreased to this value. Now as the time progresses, this will decrease in this linear fashion with a slope is equal to minus k. How this minus k is obtained slope? You know that this is y is equal to mx plus c. Just now we have told. So here m stands for the slope. So m, when you compare, you will get minus k. So that's the reason why slope is equal to minus k. And we know that slope have another equation. Slope is nothing but tan theta, which is equal to m, correct? So tan theta, how you can find tan theta here? Just to draw a triangle. Okay, so draw a triangle, let this be theta. Then tan theta is equal to opposite side. So take this value from the graph. Okay, take this value from the graph, then divide it. So this part I will say dy, and this part I will say dx. So tan theta is opposite side by adjacent side. So here a of t during this interval divided by time interval between this. So if you take a bigger triangle also, you will get the same value since it is a ratio. So that is how by graphically you are finding out the slope, which is nothing but my rate constant k. So please remember, for a zero order reaction, slope is the rate constant k. Very, very important. Now let's try to define what is half-life for a zero order reaction. Okay. Okay, so next we will try to see what is half-life of a zero order reaction. So before we are trying to derive that, first of all, what we should understand, what is half-life basically. So half-life is very simple. It is the time which is required for the reactant to become half of the initial concentration. So if you see here, the half-life of a reaction is the time in which the concentration of the reactant will reduce to 1/2, 1/2, one half of its what? Initial concentration. Okay. Now let's try to see for a zero order reaction, how will you derive this equation? Very simple. The first equation we have learned this. A of 0 is equal to, or we know that A of t is equal to kt plus A of 0. So I have rearranged it. So I can say k is equal to A of 0 minus A of t by t. Don't worry, this is the same equation we have just seen before. I have rearranged it to get the k value. Okay. Now we know that. Now let us apply the t half. So let t half, applying t half means what actually? At a time t is equal to t half. So what is this means? This means that after half-life or after half time. So t, when it becomes equal to t half, what will happen to the concentration A of t? We can say that A of t will become, as per the definition, the concentration will become half of the initial concentration. Initial concentration was A0, it will become half of that. So A0 by 2. Correct? Now we can apply this. On applying this, what will happen? K is equal to A0. This will not change. Correct? A of t will become what? A0 by 2. So A0 by 2 divided by, what is the time at that point of time? T half. So I will apply t half. Now take the t half here because I am deriving the equation for t half. So t half is equal to A0 minus A0 by 2. What is that? We know that 1 minus half is half only. So we can say A0 divided by 2. Then k I am taking in the denominator. It will become k. So what is the final equation for t half for a zero order reaction? So this will become t half is equal to A0 by 2k. So this is the final equation for a zero order reaction. Very important. If it is zero order, then only please apply this equation to find out the t half. And from this you can understand one thing. T half is directly proportional to A0. Correct? 2 and k. K is a rate constant, that is already a constant. So we can say t half is directly proportional to what? Initial concentration. In which case, for a zero order reaction. So I can say, if I draw a graph, for example, let me rub this. So if I draw a graph between t half and A0, can you say how the graph look like? Okay. So let me say, if I am going to draw a graph t half versus A0. So again it is for a zero order reaction. So how the graph looks like, can anybody tell? Since we know it is directly proportional, it will be a straight line. So I can say T half and this is my A naught. Okay, this is my A naught and this is my T half. Or usually we say time in the denominator, in the x-axis. So we say here T half. Okay, and this is my A naught. So how the graph looks like? So the graph, it will be a straight line, because from this equation we could understand T half is directly proportional to A naught. So that will be a straight line. So please remember, graph will be a straight line. This is applicable for what type of reaction? Zero order reaction. We have derived for zero order reaction. So I hope you understood, got a fair idea. So in the next class, we will try to see how to derive the integrated rate equation or differential rate equation for a first order reaction. Okay, then we will see second order, then we will see nth order. Okay, so this is the general idea. And if you have any doubt, please get back to us. Please keep on writing the notes, very, very important. If you have any doubt, please ask the same thing in our doubt clearance session. Okay, also you can post it in our WhatsApp group. Thank you.
Hi dear students, so welcome you all to the another session of Brainiacs doubt clearance. So today we are starting with the chapter chemical kinetics. So I hope you could all see the question. It's a very good question that came for Neet. Okay, so let's see. The rate constant of the reaction A converting to B is given as 0.6 into 10 power minus 3 mole per liter per second. If the concentration of A is 5 molar, then the concentration of B after 20 minutes is. So this is the question here. Okay. So here, what we need to do, first we need to understand the question, then we try to answer it. Okay, so here the question does not mention anything about the order of the reaction or what type of order, whether it is a zero order, first order, nothing it is mentioning. Okay, but there is a clue to find out that. So we will discuss that first. How to identify the order from this one. Okay, so the first thing we need to check here is we need to see the unit of rate constant. So let me write the unit of rate constant given here is K is equal to, the unit given here is mole, correct, per liter. So liter raised to minus 1 and second raised to minus 1. So this is what they have given in the question. Now from this there is a shortcut to identify the order of the reaction. Okay, I will tell you this shortcut. Very easy. Always take the unit of liter. Okay, which one? Always take the unit of liter and take its coefficient. Its a coefficient. For example, here liter raised to minus 1 is given. Correct. So take this minus 1 and add 1 to it. So its value is equal to 0. Then 0 will be the order of the reaction. So it is a 0 order reaction. Understood? So it's very easy. But always take rate constant. Then identify the coefficient. How much the liter is raised to 2. So if it is here, it is raised to minus 1. Then always add plus 1. So this will become 0. Okay, suppose if liter quantity is not present, then make that coefficient value as 0, then add 1, then it will be first order reaction. If it is liter raised to 1, then add 1, then it is equal to 2, then it means it is a second order reaction. Understood? So this is the easiest way, but always take the rate constant and its corresponding unit. Okay, now we understood it is a zero order reaction. So for zero order reaction, what is the equation? We have learned the integrated rate equation. So we say for zero order reaction, we can say concentration of A is equal to initial concentration, correct? So initial concentration minus rate constant into time t. So here what we assume, actually we can say that here we assume a reaction where A is getting converted to B. Okay, let me take another color. So we say a reaction A was initially present, so it is getting converted to B, correct? So we can say the change in the concentration, for example, we can say like initial concentration was A naught, correct? This was the initial concentration. So what happened after some time, it has decreased to a final value A, correct? So initially A0 was present, correct? Now after, this is at time t is equal to 0, at time t is equal to 0. Now after some time, at time t is equal to t, what happened? A0 changes to A. Now when A0 is changing to A, that is decreasing, what happens at the other end? B will be formed, I mean the product will be formed. Initially no product was there, so this is the transformation. Understood? So we can say this change in the concentration A0 to A, that decrease will be equal to what? The rate of formation of B. So we can say A0 minus A, this is equal to what actually? The formation or the amount or the molar concentration of B. So but we already know that from equation 1, we know that A minus A0, A minus of A0. Okay, let me rub it, it's not clear. Okay, so we can say from the initial, from equation 1, we can write from equation 1, we know that we know that what we can write, we can write a0 a0 minus a, just rearranging the equation 1. Okay, minus a is equal to k into t, correct? So I mark this as equation 2 and this as equation 3. Now from 2 and 3, what I can write? From 2 and 3, I can write the concentration of B is equal to K into T. What is K here? The rate constant that is given in the question. So what is the value that is given in the question? If you see here, 0.6 into 10 power minus 3, correct? So I can substitute that. 0.6, okay, let me rub it. 0.6, 0.6 into 10 power minus 3 multiplied by time. So they are asking you at what time they need to know the amount of B formed. We will see. Okay, so they have given it like after 20 minutes they want to know, correct? So we will substitute there 20 into 20. Okay, so if you calculate this, what will be the answer? You are getting 0.72 molar. Okay, so I got the answer, that is the amount of B formed after 20 minutes is equal to 0.72 molar, correct? So which one is the correct answer here? So the concentration of B after 20 minutes is 0.72 molar. So I hope you understood the question. So very important point here is identifying the order. So very simple, take the rate constant, take the liter unit, identify the coefficient power, whether it is -1 or +1, whatever it is. -1, it can be usually -1, 0, +1, like that it goes. If it is -1, it means add +1 and identify the number. So it is 0, so that indicates it's a zero order reaction. Then use the integrated rate equation for the zero order equation, then you will get the answer. So thank you for patiently listening to it. Hi dear students, we have a new question in front of you. So today we are dealing with the chapter chemical kinetics. I hope you could see the question. In a reaction A plus B giving you product, the rate is doubled when the concentration of B is doubled, and the rate increases by a factor of 8 when the concentration of both the reactants A and B are doubled. The rate law for the reaction can be written as. Okay, so this is the question. So this is a previous question that came for Neet. So here the idea here is, first we will try to assume a rate law. Okay, we say rate law R is equal to rate constant, and we know the reactant first one is A, and we don't know the order, so we assume it as M. and the next one is the reactant is B, and we assume its order as N. Okay, now we need to identify this expression. So it was told like the rate is doubled when the concentration of B is doubled, initial case. So we say the rate is doubled means we say 2 times R. When what is happening when the concentration of B is doubled? So we say A is the same and the concentration of B becomes 2B, correct? 2B raised to N. We say this as equation. This is equation 1. This is equation 2. Now the next statement says that the rate increases by a factor of 8. That means it becomes 8R when the concentration of both got doubled. So we say this is 2A times M and this is 2B times N. And we say this is equation 3. Now we will try to do this equation. So we say divide equation 1 by 2. Why we are dividing equation 1 by 2? Because if you divide that, we have the common factor A that will get cancelled off. So that we will get the order with respect to B very fast. Understood? So we divide. So this becomes R divided by 2R is equal to K by K. Here A power M, correct, and B power N, and in the denominator what will come? A power M, correct, and 2B raised to N. So we know that this will get cancels off, correct? So this becomes R and R will get cancels off. So this becomes 1 by 2 is equal to, both are same, so here B will get cancels off. So we can say 1 by 2 whole power N. Now if you compare these two, we can say both are 1 by 2. So N will be equal to what actually? 1. Correct. So similarly, now we know the order with respect to B, that is 1. Correct. Now similarly, we will try to find A. Let's see how to do that. To get A, I may say we can compare equation 2 and 3. So divide equation 2 by 3. So equation 2 divided by equation 3. So if you do that, it will become 2R divided by 8R, correct, equal to K, this is A power M, and this is 2B raised to N. And if you are dividing, this will become K and this will become 2A power M and this will become 2B raised to N. Now why I have chosen 2 and 3? Because in that the concentration of B is remaining the same. So I can cancel this 2. So this will get cancelled off and this will get cancelled. This R will get cancelled. So if you divide, this will become 1 by 4 and this is equal to A and A will get cancelled off. So 1 by 2 whole power M, correct? So now tell me 1 by 4 can be written as how we can write 1 by 4? 1 by 2 the whole square is equal to 1 by 2 the whole power M. So from this I could understand M is equal to 2. Now tell me you got M and N. Now how you can write the rate law expression? So I can write the rate law as R is equal to K into A power 2 and B power 1, because it was M and N initially. So I got M and N value. So this was M. You remember the first equation K, this was A power M and B power N. So I substituted M and N values and I got this expression. R is equal to K into A power 2 and B power 1. So let's see whether that is present in the options or not. Okay. So in the options A power 2 and B power 1, it is present in option B. So my option B is the correct answer. I hope you understood, you got a fair idea. Okay. Hi dear students. So we have a new question in front of you. This is from the chapter Chemical Kinetics. So this is one of the good question that came for Neet. I hope you could see the question. I will just read the question. Okay. The rate of the reaction 2N2O5 getting converted to 4NO2 plus O2 can be written in three ways. That is, d by dt of concentration of N2O5 is equal to rate constant times concentration of N2O5, and d by dt of concentration of NO2 is equal to k dash into concentration of N2O5, and d by dt of concentration of O2 is equal to k double dash concentration of N2O5. The relationship between k dash and k double dash. So if you see, they are asking the relationship between k and k dash and then between k and k double dash. This is what the question is. So this is from the fundamentals actually, this question. So let's write the equation. The rate of disappearance of the reactants, we know that it is equal to the rate of formation of products. So how I can write? So disappearance rate of disappearance of reactants is equal to the rate of formation of products. This we are learning initially itself, correct? Based on this fundamental only we are measuring the rate of formation of products. Okay, now can you write what is the rate of disappearance of reactants? I can write it like the rate of disappearance of reactants can be written as minus, since it is reactant I should put minus 1 by 2, that is coefficient of N2O5, then d by dt, so d by dt of concentration of N2O5, correct, is equal to what? 1 by 4, correct? You need to take the coefficient of NO2 and keep it in the denominator. I have taught you. Okay. D by dt, this will become positive. Why? Because the products are always forming. So it is represented by positive symbol. D by dt of NO2, correct? Which is equal to, we know that formation of two products are there. So d by dt of O2, correct? Now, in the question, they have already given what is d by dt of N2O5. If you see here, you could see that actually. Okay, what they have given, minus of d by dt. So if you see here, minus of d by dt of N2O5 is equal to k times N2O5. So what I can do, I can substitute that. So if I substitute, so this will become k by 1 by 2 will 1 by 2 will be there. Instead of minus d by dt of N2O5, I am substituting what actually, k into concentration of N2O5 from the given from the given terms. Now similarly, I can write d by dt of NO2. How I can write? I can write 1 by 4 k dash, correct, k dash N2O5. This is from which equation? From the second equation, correct? Now from the third one, what I can write, this is equal to d by dt of O2 is equal to k double dash N2O5, correct? Now if you compare the three, I can say N2O5 is a common factor, so that I can cancel off. So this is getting cancelled from everywhere. Now I can compare this. So they are asking you the relationship between what and all, k dash and k. So k dash and k. So I let me compare these two. So I can write k by 2 is equal to k dash by 4. So this will get cancels off. So I can write k dash is equal to 2 times k. Correct? Similarly, they are also asking you the relation between k double dash and k. So let me compare these two. I will take another color for your understanding. So these two they are asking you to compare. So I know that k by 2, correct, is equal to k double dash. So it's a direct thing. So k double dash is equal to how much it is coming? K by 2, correct? So let me see whether any options are there similar to that. So k double dash is equal to k by 2 and k dash is equal to 2k, correct? So option B, it's almost the same answer we have got. So option B is the correct answer. So I hope you understood the question. It's very simple, just clear, just a simple concept. The rate of disappearance of reactants is equal to rate of formation of the product. Then they have already given this rate of disappearance in terms of reactants everywhere from the whole three equations. Just to substitute that and identify the relation. That's it. Okay. So if you want to know, hi dear students, once again welcome back to Brainiacs doubt clearance session. So here we are having a question from the chapter chemical kinetics. So I hope you could see the questions clearly. Okay, let me read the question. For the reaction N2O5 getting converted to 2NO2 and half O2, the value of rate of disappearance of N2O5 is given as 6.25 into 10 power minus 3 mole liter raised to minus 1 second raised to minus 1. The rate of formation of NO2 and O2 is given respectively as. Okay, so this is what you need to find out. So let's rewrite the equation one more time. So we have N2O5, correct, which is in gaseous format, is getting converted to 2NO2, 2NO2, which is in gaseous format, plus half O2. Okay. Now, again, it is based on the same concept. The rate of disappearance of products is equal to the rate of formation of the rate of disappearance of reactants is equal to the rate of formation of products. Okay, so here the reactant is N2O5. So let's write here minus, correct, d by dt of concentration of N2O5. It should be equal to what? Take the coefficient and take the reciprocal of this, correct? So 1 by 2 d by dt of concentration of NO2, correct? And please listen here plus symbol will come. Why? Because it is a product, so it keeps on forming, its concentration is increasing. Now next one, you have half is the coefficient, so take the reciprocal, so 2 will come in the numerator, so d by dt of O2, correct? Now what is given there? They have given the rate of disappearance of N2O5, so that is they have given to you. So we can substitute that, and from this we will identify the rest of the things. Okay, so let me substitute here. So I can say d by dt of N2O5, it is already given as 6 point, if you see here, you could see in the question 6.25 into 10 power minus 3. So if I substitute here 6.25 into 10 power minus 3, correct? So mole liter raised to minus 1 second raised to minus 1, which is equal to plus 1 by 2 d by dt of NO2. So let's first find out the rate of formation of NO2. So rate of formation of NO2 is nothing but d by dt of NO2. Please understand, it is just d by dt of NO2. So what will be the answer? You can take the 2 here. So this will become 6.25 into 2 into 10 power minus 3 mole liter raised to minus 1 second raised to minus 1. Correct? So what will be the answer? 6.25 into 2. It will become 1 point, correct? 1.5, around 1.5 into, okay, 6.25 into 2, if you multiply, this will become 1.5 or 1.25 it will become. Okay. So 1.25, 1.25 into 10 power minus 2 mole liter raised to minus 1 second raised to minus 1. So if you have doubt, you can just multiply it and see. So 625 into 2, how much it will come? 5 into 2 10, 2 into 2 4 5, 6 into 2 12, correct? So 1250 into 10 power minus 3. So if I, what you should do, divide by 10. So 1.25 means divide by 1000, so multiply by 1000. So how much it will come? So here you know that 625 into 2 is 1250 into 10 power minus 3. Already it is 6.25. So that means this will become 12.50, correct? 12.50 into 10 power minus 3. So this can be written as 1.25 into 10 power minus 2. Correct? You can see that. So this is just a simple calculation. You can do it. Now, similarly, tell me what and all things to be compared now. Here, one more time, I can write 6.25 into 10 power minus 3 mole liter raised to minus 1 second raised to minus 1 is equal to, this time I will compare with oxygen, 2 times d by dt of O2, correct? Now I need to identify the rate of formation of O2. So rate of formation of O2 is nothing but d by dt of O2. Then what will happen to the 2? 2 will come in the denominator. So I can say 6.25 into 10 power minus 3 divided by 2. Correct? So what will be the answer here? You can just calculate it. This will become 3.125 into 10 power minus 3 mole liter raised to minus 1 second raised to minus 1. So let me see whether this answer is there. So the rate of formation of O2 I have identified, and the rate of formation of NO2 also I have identified. So let's see whether this is present in the options or not. So in the options, yeah, 1.25 into 10 power minus 2 is present. That is the rate of formation of NO2, and 3.125 into 10 power minus 3 is also present. So option B looks the correct answer. Understood? So this is an easy question. So if you need any detail. Hi dear students, we have a new question in front of you. This is for the doubt clearance session of the chapter Chemical Kinetics. This is one of the good question, and the question is very easy, but this question has repeatedly asked many number of times. The question here is the rate of the reaction 2NO plus Cl2 gives 2NoCl. Okay, is given by the rate equation. Rate is equal to rate constant NO whole square concentration of Cl2. The value of the rate constant can be increased by. So this is the question. So please understand that I have given you in my lectures also the rate constant K. It depends. Okay, this depends only on two factors. I can say the first factor is temperature and the next factor is catalyst. Correct? It does not depend upon the concentration of the reactants. So how K and temperature, rate constant K and temperature are related? This is related by famous equation, Arrhenius equation. Arrhenius equation, very important. This is there in your syllabus. We need to learn that. Okay, I will give you that relation for your understanding. The rate constant, okay, I will take another color. The rate constant K is equal to A into E times minus EA by RT. Correct? So here K is the rate constant. K is the rate constant. Correct? And what is A? A is called Arrhenius factor or frequency factor. We say frequency factor or Arrhenius factor. And T, as you know, it is the temperature, correct? And R is the gas constant, and EA is the activation energy. Activation energy. Okay, this we will learn as a separate topic, this Arrhenius equation. So from this question we can understand that the value of the rate constant can be increased, or it can be changed only by what? Increasing the temperature. Understood? So this is a very easy question. Please remember K depends only on two factors, that is temperature and the next one catalyst. So if you need a detailed theory of this chapter, you can